Assalamu alaikum wa rahmatullahi wa barakatuh. In this video, we will talk about 2 points. The first one, which is calculating the equilibrium constant, and the second, what is the relation between Kc and Kb, and how to calculate one of them in the presence of the other value. Okay, so let's first start with calculating the equilibrium constant. So here we have a chemical reaction, which is 2N2 gas. This one will react with oxygen, and the product will be N2O gas. Okay, for this reaction, we need to calculate Kc, so it's unknown, and the givens are the concentration of N2 equals to 2 times 10 to the negative 4 molar, and the concentration of N2O equals to 0.2 molar, and the concentration of oxygen gas equals to 0.00245 molar. So how to solve this question? So first we will start by writing the expression for the equilibrium constant, so Kc. Kc is equal to product, concentration of products over reactants. So we have only one product and we have two reactants. So the product will be N2O, and we have an exponent here because we have a coefficient 2, so it will be to the power of 2. Here down for the reactant, we have two reactions. The first one, N2 to the power of 2 multiplied by the concentration of O2. Now we'll just plug in for the values that we have, or substitute for the values here. For N2O, we have this value, 0.2 to the power of 2. For N2, the value is 2 times 10 to the negative 4, and again to the power of 2. And for oxygen, 0.00245. And we need only to use your calculator, and the value, final value, would be 4.1 times 10 to the power of 8. So this is an example how to use. So it's easy. You need only to write the expression and what the values that you have. Second example, and again, we will use the same thing. You have a reaction, Na2 gas plus 3H2 gas. And this one will be converted to 2NH3. This is the ammonia synthesis here. And for this one, we have the pressure for NH3 is given as 3.1 times 10 to the negative 2 atmospheric pressure, and the pressure for Na2 is equal to 8.5 times 10 to the negative 1, again atmospheric pressure, and the pressure for hydrogen equals to 3.1 times 10 to the negative 3 atm. Of course, it's here asked for the Kb because it's all the givens by pressure. So first, again, we have two steps. The first one, write the expression for the K and then substitute for the value. So the Kp is the pressure for products over pressure for reactants. So pressure for NH3 to the power of 2 over the pressure for reactants. We have 2 pressure for Na2, and we have no exponent for this one, multiplied by the pressure for hydrogen to the power of 3. Now we need only to put the values and substitute. So the pressure for NH3 it's equals to 3.1 times 10 to the negative 2 to the power of 2. For nitrogen, it's 8.5 times 10 to the negative 1. For hydrogen, it's 3.1 times 10 to the negative 3. And don't forget, you have an exponent here, it's a 3. And you need to find the value with the calculator, so it will be 3.8 times 10 to the 4. It's about 4. So it's easy if you have the values for the concentration or pressure, and he asks you to find the Kb or Kc. Now we will go for the relation between Kc and Kb. We said that both are equilibrium constant, but one by using concentration and the other by using pressure. And we have a relation between them. Kp equal to Kc times RT to the power of delta N. Okay, so this is the equilibrium constant by pressure, and this is the equilibrium constant by concentration. R is the universal gas constant. We know that this one is the gas constant, universal gas constant, and this one is equal to 0.0821 atmospheric pressure multiplied by liters over mole Kelvin. And T is the temperature, and the temperature here will be measured by Kelvin. Delta N is the sum for number of moles, or difference of number of moles, and this different number of moles will be moles of products minus moles of reactants. Okay, let's see how to use the formula. Okay, we have an example here. So we have a chemical reaction A, plus 2B, and this one will be converted to C plus D. Okay, what we have the Kc value, which is 1.06 times 10 to the negative 3, and this one at temperature equals to 25. Calculate the Kp. Okay, so let's start here. First, I will convert the temperature to Kelvin because it's given as Celsius. So I will add 273. So this will give us 298 Kelvin. Now we will write the expression. We have Kp equal to Kc multiplied by RT to the power of delta N. Okay, this one is the unknown. We have this one. R is a constant, so it's a given. Temperature is a given. A number of moles given as long as we have the equation. So I will just substitute for the values. So Kc is 1.60 times 10 to the negative 3 multiplied by R, which is 0.0821 multiplied by the temperature 298, and this will be raised to the power of number of moles, or the number of moles of products minus number of moles of reactants. Let's calculate number of moles of products. Number of moles here will be taken from the coefficient. So we have 1 and 1, so the product are 2. And we have 1 and 2, so it's 3. So products are 2 and reactants are 3. And you need to calculate this one by your calculator, so it will be 6.54 times 10 to the negative 5. So this will be Kp. We'll take another one. We have a different reaction again. So we have N2O4, which is a gas. And this one will convert it to N2O, a gas. And again, what is the given? We have Kb this time. Kb is equal to 136. And the temperature is 55. Again, it's Celsius, and you want to calculate the Kc. Okay, so what we are going to do, first I will convert again the temperature to Kelvin. So I will add 273, so it will be equal to 328 Kelvin. Okay, the expression is Kp equal to, or the formula Kc RT to the power of delta N. So I need now to calculate Kc because this is the unknown. So I will divide by RT. So it means Kc will be equal to Kp divided by RT to the power of delta N. Okay, now we'll substitute. Kc equals to Kb, which is 1.36, over R, which is 0.0821, multiplied by temperature 328 to the power of delta N. Again, what is delta N? Number of moles of products minus moles of reactant. Moles of products here are 2, and reactants 1, because we have only one reactant. You can calculate this one by using calculator, and the value will be 0.05.